Good evening and welcome everybody. This webinar is about modern web development. I am Jebin. I'm a software architect, an author, full stack engineer, front-end specialist, and also a tech polyglot. I've worked on multiple products and projects, including analytics and BI solutions, web messengers, message delivery systems, bot platforms, including the application and intelligence layer. And I am also contributing to carrots.com, which is a curated knowledge building platform. I'm also part of itbytes.in, which is a training initiative to bring up individual contributors for the industry. That is all about me. And this webinar is an introduction to modern web development. When we talk about modernity, we also need to talk about the evolution of web. In the beginning, there were simple HTML pages. And then we needed presentation, because of which CSS was introduced. And then we needed interactivity, because of which we got JavaScript. And the evolution didn't stop there, that we got a lot of improvements in all these three technologies. HTML, we are anticipating 5.2, and in CSS, we already got CSS2 and CSS3, and we are anticipating CSS4. And in CSS2 and 3, we got a lot of goodies, including transition, animations, and other presentation effects. When it comes to JavaScript, again, the evolution was humongous, that we got ECMAScript 5, and then 6, 7, and 8, and still we are counting. If you see, ECMAScript 6 brought us a lot of good and cool features in JavaScript, including arrow functions, spread operators, and a few more. And ES7 got us async and await, which is one of the best features, I would say. And in ECMAScript 8, I'm anticipating pipeline operator, which is really a good syntax to use if you are doing pipings. And if I have to talk about evolution, I cannot just pass through without mentioning JavaScript frameworks. Libraries like jQuery, MooTools, YUI, and also frameworks like Backbone, AngularJS, React, Vue.js have contributed to the adoption of JavaScript tremendously. Now, if you ask me, every evolution that happened over the decade has been driven because of a dire need. And if you ask me about the evolution of web, what is that one reason that drove the evolution of web would be user experience and their expectations. Of course, the initial user expectation were simple HTML pages, and then it moved on to have some presentation wherein we wanted the content to be in proper layout, and we wanted colors here and there, and we wanted to emphasize text according to our need. And then we needed interactivity, because of which we introduced JavaScript, and that interactivity has grown to an extent. These days we have full-blown web applications with user experience at its center. The user experience is an important thing when we talk about web, at least in the past decade. In terms of user experience, colors, presenting the elements, having subtle animations, positioning the elements in the right places of the web page are all considered important attributes. But along with these, one of the most important and major contributor for user experience is performance, which is often forgotten. If anybody is developing any serious websites or web applications, they need to consider the performance as the fundamental user experience. If the performance of a particular web application is not really good, obviously the user experience will also be not good. The user experience must be always taken into care, which means performance must be given first preferences. That is where anybody who is developing web applications must consider performance budgets. So when I say performance budgets, it's nothing but the payload size which is delivered to the browser on request. The lesser the payload size, the better the experience will be. And also when I talk about evolution of the web, we also need to talk about the rivalry of web applications. And today's market, mobile has thrived a lot, and we have native applications as one of the important rivalry for web applications. But what is the problem with native applications that people are moving towards web applications even for the mobile world? The important problem is that any average user can notice that their mobile phones will have 20 to 30 applications, out of which only 5 or 6 are the ones they are using in their day-to-day life. And the rest are consuming space, they are consuming bandwidth and unnecessary resources. And the next important problem is with all this unnecessary items, we are also having distribution problem, update distribution problems. Whenever there is a updates, security patches which needs to be released to solve problems in all these applications, then of course we have to actually be dependent on the web stores. And also it is not guaranteed that the users might download all these updates. But this problem doesn't happen in web applications, because once you reload the page or revisit the page, you get to have the latest content from the web applications. It is one of the biggest problem solvers and important reason why people are moving towards web applications. As I said earlier, the evolution of web, if we have to talk about it, we cannot pass through without mentioning the importance of JavaScript frameworks. And in the beginning, we had Backbone.js, which provided us MVC, which was doing good, but then it had a lot of other problems as well, because of which people started looking out for other frameworks. And there we got Angular 1, which did a job so well. But unfortunately, it also failed for various reasons, performance reasons. And then we got Ember, which was really good for a team. But it's huge, it had its own learning curve. And that is where we got React, which is ruling the world today. And Vue.js is again catching up. Unfortunately, Angular, because it has to take a detour from its development and concepts, it's again in the catching up mode. But there are other promising micro frameworks as well, which are providing all the features that these major frameworks and libraries are providing. Now, if we observe keenly all these frameworks, what are the common attributes of these frameworks? One is these frameworks are providing two-way binding, if not all, at least some of them, and efficient DOM refreshing with the help of virtual DOM, because most of these frameworks do DOM difference, and then they update only the portion of the DOM that is needed to be updated, which is all good. Now, if I have to give you some metrics, the internet and the web, the pages that we are seeing all over the internet, has 20% of their websites having jQuery, and also 3% of the whole internet websites have Bootstrap. Those are pretty big numbers. And along with that, any serious application these days, whoever is building, are using one or the other framework to help them with their tasks. So what that means is, according to the HTTP archive, the statistics says that by the end of 2015, average page size was 2.2 MB, which means JavaScript is contributing to the performance budget, which is the payload size of the HTML pages. Now, what is the effect of this? The more the JavaScript content, the more is the load time. And because of that, of course, the execution time also increases. And with those execution time, the biggest problem that comes is with the user experience, wherein the user will not be able to interact until all the JavaScript content is loaded and all the DOM events are bound to the DOM elements, and then the interactivity starts. So now that is a big problem. This is a comparison between JavaScript and JPEG just to show you how much time and how much resources it can consume when it comes to JavaScript and how much it does when it comes to JPEG, an image. So if you see here, the JavaScript and JPEG of size approximately 170 KB, it takes 3.5 seconds for JavaScript to load and execute. But when it comes to JPEG image, it takes less than 100 milliseconds, which is way far when compared to JavaScript. So this is what we are talking about when it comes to performance. The more the JavaScript, the more the load time is, and the more the load time, the interactive time from the time it loads to the time the user interacts obviously increases. And this metric of performance is called time to interact. So if I have to introduce you to the vocabularies of modern web development, the first thing that I need to introduce is time to interact. As a plain and simple definition for time to interact metric would be, let's say a user is looking for a particular website called example.com. So from the moment he enters and enters that URL in your browser to the moment he sees and is able to interact with that web application or website is the interval which is called time to interact. The lesser the time to interact, the better the user experience will be. Now, these days, any website that we see will have enormous amount of payload, including HTML, JavaScript, and CSS. And especially in parts of JavaScript, we have lots of libraries, including jQuery or Bootstrap or one of the frameworks, which will contribute to major section of your payload. So how do we reduce this payload? Because these are essential components of every web application. Now, how do we reduce them so that this time to interact will also be reduced so that the user experience will be delightful? To answer that question, the solution is server-side rendering. In the good old days, server-side rendering was happening phenomenally that there was not much client-side rendering happening. So people used to develop and build all those HTML from their server-side logic, and they were delivering that HTML content as the payload to the browsers. So in the good old days, server-side rendering was happening, but then as JavaScript evolved and people started adapting to the new techniques of JavaScript, people started moving away from server-side rendering and they started doing a lot of client-side rendering. If you take a typical single-page application, we do complete web page rendering with the help of client-side rendering. So what happens in client-side rendering? We send all the templates and the data to the client so that the client itself can take the decision and build the HTML and render the content for the user to work or to interact. Now, the problem with this is the client-side interaction is it will increase the time to interact because you are sending the data. Along with that, you are sending the template, and along with that, you are sending the rest of the HTML content as well, or other assets as well. So this will increase the time to interact metric. So how do we reduce that? So we were using actually server-side rendering, and then we moved on to client-side rendering. Now the trend is to have a balance between server-side rendering and client-side rendering. That is how you can reduce the time to interact metric. So how do we do that? How do we have a balance between server-side rendering and client-side rendering? So here we go. What happens is, in a typical server-side rendering, when a request is sent to the server, the data will be populated and the required HTML content, which needs to be populated only for the viewport. That is what the noticeable part here. Only for the viewport will be sent back in the response. And also, the required CSS to style the viewport area of that HTML will be inlined along with this HTML, which is called the critical path rendering CSS. And there are a lot of tools available which can do this, which can extract the critical path rendering CSS, and you can inline that along with the server-side content that you are sending to the browser. But after this, where do we put or employ client-side rendering? Because client-side rendering needs data and also needs access to the template so that it can take control of the rest of the application. Now, of course, when you have all the HTML ready already, you can allow the users to interact with the web application to some extent. But after that, what is the important thing is to have the event binding in place so that rest of the interaction can be carried forward. Now, the client-side rendering should be taking care of this, but before that, we have to prioritize the task that needs to be done. So in that sense, what we need to do is, once the content is rendered and then the JavaScript is loaded, we have to do the event binding, and those event binding will give immediately way for the users to interact with the web page. So that reduces time to interact metric. But then what about the data? How do we give the data to the client-side rendering logic so that it can take care of the rest of the control of the web application? It could be navigation, or it could be rendering rest of the part of the web page. It could be or other logics. Now, how do we do that? So the question, to answer that question, the data should be sent in the format, in a JSON format, along with the server-side content, or you can lazy load this data once it is necessary, so that the client-side rendering logic can consume this data and do the rest of the client-side rendering work, and also it can take control of the rest of the application interactivity. So how do we plug this data into the client-side rendering? The answer is state management. So when I say state management, most of you might be looking into, or you might be remembering some of these popular state management libraries like Redux or Flux or Vuex or ngStore, targeting each one of these frameworks. Or you can build one of your state management system by yourself, a small library or something that you can use independently by yourself. Okay, but the whole crux here is to get the data into the state management, which will act as a glue between your server-side rendering and the client-side rendering. So which means your data must be coming along with your server-side rendering, which needs to be consumed by the client-side rendering logic, which will create the state, and the states will be managed from there on through the client-side rendering logic. Hope that helps. Now, again, back to the complete application development, there are two broad modes of developing these applications. One is graceful degradation, and another one is progressive enhancement. The graceful degradation is kind of top to bottom approach, and progressive enhancement is a bottom up approach. So the difference between these two lies in the assumptions that we make during the time of application development. The end goal is all same, that we need to deliver what the user is asking for. The web app needs to be loaded on the user's screens. But when the application is developed, we need to actually assume certain principles before developing the application. So in that sense, there is two broad modes of application development. One is graceful degradation, and what do we assume while we adopt this technique? So when we do graceful degradation, what we do is we assume that the client will be having the best of resources and operating environment, which means you might be expecting the users to have a best of operating systems with best of resources, maybe 16 GB RAM, or Retina display, or you might be expecting it to have 2.9 gigahertz processor, and that is how you assume the best of devices or environment where your application will be loading. So that is the first assumption in case of graceful degradation. And then what will happen is you will switch off or disable those features which are not available in the particular device. So you start with a bigger expectation and then you keep on degrading the performance based on the availability of the features and the resources. But in contrary, what happens in progressive enhancement is your assumption is completely opposite, wherein you assume that the user will be having the worst of the operating systems and the resources. That is like maybe an operating system which you never heard of, and the resources, maybe like 512 MB RAM or IE8 or one of these worst of the or not so best environments where your application should be working. But still, in progressive enhancement, we assume that your application will be working on these environments with all the basic features, which means you will deliver the basic features first, and then you start delivering all the other enhanced features based on the availability of the features and other resources. For example, if we take service workers are available only in the latest browsers. So if you want to target IE8, then in case of progressive enhancement, you will deliver the basic feature and then you will disable all the features that are dependent on service workers. But when it comes to graceful degradation, what we will do is we will assume that there will be a service worker feature already available. We will give that feature and then we will disable them. So it's all about the assumptions that we make during the app development process. Now, out of these two modes, progressive enhancement got the best of people, and it became almost a standard these days that people started developing applications in the name of progressive web apps. Now, it has become a standard that it has the tendency, in fact, to take over the whole native application development. When I talk about progressive web apps, in plain and simple, if I have to say, progressive web apps are nothing but your application should work on any adverse conditions or on any best of the conditions. And it has certain conditions and features or characteristics, I would say, which are mandatory to be called a progressive web app. If an application needs to be called a progressive web application, then it should have these characteristics built in within this application. So the first feature or the characteristic that is expected for any progressive web application would be HTTPS. So it has to be secure. And the next one is responsive. Any device size that the user is using, the progressive web app will be able to adapt to the screen sizes and should deliver good content, and it should be able to render things properly without neglecting. And then the next important characteristics of progressive web app is offline support. How do we do offline support? Offline support is becoming popular these days, and with the help of service workers, we are able to do offline support very well. Service workers act as a proxy between the network and your device, that any request that you make from your device will be going through the service worker. And if some of these resources, like some JavaScript files or image files or some of the HTML files, are cached with the help of the service workers, you should be able to use them when there is no internet connectivity. And that is how we provide offline support. And also, the service workers are created so well, keeping in mind the versioning, because we keep on updating our systems. So once these applications are updated, we'll be able to send the updated content to the service worker, and whenever the user is using, we'll be able to prompt the user to reload the page to have the new experience. So that is how offline support can be provided with the help of service workers. And along with that, service workers also help us in terms of registering notifications and also showing notifications in mobile devices and also in desktops. And the next important characteristics of progressive web app is storage. We have to provide the ability for the users to store their content even when they are offline. So we can use one of these client-side databases like IndexedDB, or you can use even local storage to put all the content. Now, the next important characteristic of progressive web app is manifest file. Why this is important is because most of the traffic for the applications these days, web applications these days, are coming from mobile phones. So whenever the user is using a progressive web app, we should be able to prompt the user to install this application in his home screen, which is nothing but you're adding to the home screen this progressive web app. So there needs to be an icon, and also it should be having the rest of the characters in characteristics that we have spoken. And this manifest file is very important for us to mention the icons required so that we can register the application and put this and make this application visible in the home screen of the desktop or mobile phones. And notification, as I said earlier, we'll be able to actually do the notifications with the help of service workers, and notifications are also another important characteristics of progressive web app. And finally, navigations. Progressive web apps should be able to navigate within their application well enough that it should not be stuck by any chance, and that is why it is also added as an explicit characteristic of a progressive web apps. Overall, if you see, the whole web application development is moving towards progressive web apps because there is a dire need for better experience. Already we started experiencing progressive web apps, and examples I would give is Flipkart Lite, Twitter Lite, or even Tinder has actually a progressive web app. And if you go through these applications, you'll find that these are very light to use and they are very smooth and delightful user experience. And that is the power of progressive web application. You don't have to install a full-blown 100 MB or 150 MB native application. Instead, all you need to do is like adding a shortcut. You just have to add these applications to your websites, to your mobile phones, and based on, and that too you can add it based on the usage. If you are interacting more with a particular progressive web app, then the developers have the control to prompt a banner asking them to install this. So you don't have to install all the applications in the native market, I mean the web store, for you, I mean those that are not frequently used. So that is the present situation. Now, what is the future of modern web development? The future of modern web development will be HTTP2. It is a protocol. We are already using HTTP1, but HTTP2 will change the way we develop apps in the future. HTTP1 has a lot of drawbacks because it needs to do handshake with the resources, with the other party every time it makes a request, and it is unidirectional, wherein if the server has some content, it cannot send by itself to the client if required. Instead, the client has to request for the data. And also, the best practice for HTTP is bundling all these resources into one file and sending it. Let's say if you have multiple images, you convert all these images into one CSS sprite file and you send it for the HTTP protocol, because it saves bandwidth, and also it at any point of time browsers will be able to make limited number of calls, which means the rest of the calls will be queued. To address all these problems, we have HTTP2, which is already cooking up and will be available soon. If you want to experience it already, you can use Node.js, which has in Node 9, HTTP2 is already in experimental version. You can use that. And what are all the good things about HTTP2? So the first thing is you don't have to bundle anything, because the reason we were bundling in HTTP1 is because of that queuing mechanism and the limitations that the browser cannot make more than certain number of calls. In case of Chrome, it cannot make more than 6 calls per domain. But when it comes to HTTP, given that the client and server will be in a persistent connection, at any point of time, the client can request for any resource and the server will be able to send it across. And even at any point of time, if the server has some extra data, it can push those content to the client, whoever is connected. So it's bidirectional, and it has advantages wherein if you are loading a page, you can send only those content that are required for your critical path rendering, and rest of the content can be lazily loaded, which is a biggest advantage to reduce the time to interact metric. Now, how this HTTP2 is different from WebSockets? That's the next question. Because already we have WebSockets, many people are using it, but then how it is different? So the biggest difference between WebSocket and HTTP2 is compression and prioritization. WebSockets doesn't allow compression, one thing. Second thing is they don't allow prioritization. But when it comes to HTTP2, the requests can be, there could be multiple requests and the requests can be prioritized. And also it enables compression. So with HTTP2, we'll be able to build the web with far more efficiency, and also we'll be able to increase or contribute a lot to the user experience. And that is all about modern web development. So if you like this content and if you like this webinar, please let us know by clicking the like button. And also, we are planning to deliver few more webinars on various topics. And if you're interested, please subscribe to this channel. So if you guys have any questions or have joined to this webinar, if you have any questions, please post on the live chat so that I'll be able to answer. Do you have any other questions? Okay, fine. I think we don't have any questions, which is good. Okay. P. Hanindra. Sorry, okay. He's asking how to become a pro like you, sir. It's all by practice. That's all I would say. Anyways, so if you have any other questions about this topic, please post your comments. We'll be able to answer. Okay, there is a question from Bashir Mohammed. What frameworks can be used for PWA? Fine. So for progressive web apps, I would suggest using any one of these frameworks available will be very helpful, because I have personally used React and Vue.js and also Riot.js, which is a micro framework which provides a lot of other features as well. So all this, and again, AngularJS also provides these features for progressive web apps, where they all have their own set of tools and techniques bound within the framework itself, which helps us to build progressive web apps. So if you go through the documentation and let's say you are using React.js, just search in the internet how to build a progressive web app with React.js. So there are tools available with the React.js ecosystem itself, which will provide all the required support systems like service worker registration or other basic directory structure or the application structure. They will be able to provide using those tools. Hope that answers the question. Fine. Any other questions, guys? Okay, thanks, Bashir. Anything else? Fine. So if you have any other questions, please feel free to post in the comments. As and when I get some time, I'll come back and I'll answer all these questions. And I hope to see you all again for next webinars. I have a special announcement for everybody. So as I said earlier, I'm also part of itbytes.in, which is an initiative to bring up individual contributors for the industry. So by the end of February, we are planning to start a training session for handpicked 10 people, wherein we'll be doing intensive training with the help of some of the industry veterans that I know. And we'll be helping these 10 candidates to become individual contributors, and they'll be placed in various startups that we have tie-ups with. So if you know any candidate who deserves to be trained well and to be placed in a reputed startup, please let us know. Again, your feedbacks are welcome. It will help us to create quality content in the future. Please give your feedback by clicking on the link below in the description. And if you have any suggestion for a particular topic, please let us know. We'll be able to cover those topics as well in the future. And we have lined up a lot of other topics as well for the future webinars. So the next webinar is planned for Jan 25th, which is next Thursday. And the topic will be server architectures. I'll be delivering a webinar on various server architectures like monoliths, microservices, even serverless architecture, which is actually booming up. And we'll also talk about tire-based architectures and distributed architectures. So stay tuned. If you want to get notified, please subscribe, and we'll see you next week. Thank you, everybody. Thanks for joining.